Yeah, thank you for inviting me. Okay.
Take it away.
So yeah, thank you, Nash. And thank you for the invitation. It's really nice. So I'm going to talk about today about how to accurately mine collaboration interactions in Wikipedia to detect systematic social mechanisms, and I'm shortly going to tell you what that actually means. So about me, I'm a fourth-year PhD candidate and a research associate at KIT. I actually work in a computer science department of Rudi Studer, who's actually one of the guys who kind of invented semantic web. This is actually a kind of a little bit foreigner in computer science, because I was actually trained as an empirical sociologist in my undergraduate, and actually started then my PhD in this computer science area. And what I do right now is, I think nowadays described as computational social science. Also going to start my postdoc in that area soon in Cologne at GESIS, at the Computational Social Science Institute. And why I'm here, so of course because Nash invited me, and I want to talk about my thesis and set up some points for collaboration. I already talked to some of you and we saw where we could actually collaborate, and that seems very promising. So, and the plan is actually to come June 30th until August 15th, to stay 1.5 months here and actually see what we can do. Actually, already saw that Aaron and Cindy, for example, have some time actually to work with me. That was good, and Anoop also was interested, so that's really good. Yes, so the talk actually will cover what I mean by social mechanisms, because that's not completely self-explaining, and what I mean by that in Wikipedia, how I mined, that's work that I already did, collaboration interactions in the writing process, and revert and antagonistic relations, and then how I plan or do represent these interactions in metrics and models, and then a short part on what services or interfaces you can build on top of that. So, what do I mean by social mechanisms? So this is a typical, probably a typical scenario which each of you knows when you go home from a big sports game, or you want to find a parking lot and there are no signs, or you want to get out of a building and you don't know how. Use the normal individual level heuristic of following the social proof of where everybody else is going. This is usually something really useful. Yeah, you would do that, and on a little bit higher level, this would mean that actually everyone, if no one has really information about it, everyone would follow the guys before them, and this is kind of this information cascade behavior. I'm not taking the word wisdom of the crowds in my mouth because it's too much of a buzzword here, but actually just a little bit higher level interaction of having a social information cascade, for example. So this is a kind of a mechanism that appears in many scenarios. So let's go to this example of the concert, for example. So you try to find the exit. You might not have any information about where to go. You might have contradicting information with the mass, but you will neglect it, and you will just follow the guy in front of you or the guys in front of you if it's more than one. So this was what was described as information cascade, for example, or social proof. So this is what Hedstrom and Swedberg actually, and Coleman before them, described as social mechanisms. So it's not on the individual level, it's not a grand social theory, but it's somewhere in the mid-level, describing something that's appearing in many kinds of scenarios, also can be combined with other social mechanisms. But they come from these individual heuristics that you see very often. They're just natural to humans. Another example would be the stock market, for example. It would be the same. You don't know if you should buy or should not buy. So they could turn out really well. So you go find the exit and you discover opportunities for profit, or it can turn out really bad if you follow the crowd in the wrong direction. Then you create a stock market bubble, or you have mass hysteria and there's a panic. So just keep in mind that these things usually are really useful. That's why the evolution brought them actually forth, so they actually exist, but not necessarily, so they can turn bad. Especially if people do not act independently in this case. So this is information cascades, for example. Then we have, for example, protection or isolation, where you get attacked or your group gets attacked, and you actually start protecting your property or yourself against intruders or attackers, which usually has a purpose, which is securing yourself, security, or you can overprotect. So that means that you don't get any collaboration anymore, for example, on your stuff, or you don't get any useful input that you would get usually. Then another one would be group formation and group identification. So that's usually a good thing. Everybody profits from it, but it could also turn out into bipartisanship or and this group behavior, this camp behavior, where you would not collaborate just because the others are from a different group. So these are just three pretty well-known examples of that. So that, and it also shows that they can turn out badly. So where do they exist, these mechanisms? So probably everywhere in society, but I wanted to look at where they exist online and online collaboration platforms, and especially Wikipedia, because this is an important platform. It has, you get so much information from it. It has over 50 million users per day, unique visitors per day, reading information on Wikipedia. And I'm going to talk about the English one here, because there's most research is on the English one, but I have to admit that it's a neglected area, actually. That's not many people do a lot of stuff on the different language versions, which should be done. But I do the English one now. And
you know that Darren Gogol, that is one of his projects.
Yeah.
Comparing
now they're starting to do
yeah.
do the comparisons also for fact mining. Some colleagues of mine do that,
Yeah.
for example, for semantic entity recognition and this kind of stuff. So it's slowly emerging, but
Yeah.
I will focus on the English one. So the question here would, do these mechanisms exist actually in Wikipedia, and how would they look like, and what would be their effect, for example? So that was where I started out from, because I'm pretty sure that they also exist in Wikipedia. And what does it mean for the collaboration network, and then the content that actually emerges? And what could we do with that? So the first thing I did was looking for indicators for these mechanisms. Let's take these three that I had and look for indicators that they exist. So I did the literature review, and actually you can find in several papers, you can find, for example, this social proof, information cascade, or conformity behavior, where old words rarely get changed. Things get consolidated articles, and they're really, really hard to change anymore, because everybody believes that they must be right because nobody changes them anymore. Then there is, for example, this camp behavior, where you have this example where conservative people dropped out of Wikipedia, because the camps were so fixed, the liberals and the conservatives, about, for example, intelligent design or evolution, that they could not find a consensus, so the conservatives just dropped out and built their own conservapedia. Then you have this kind of camp behavior, this kind of protection behavior, which was described as ownership behavior. So this is a very interesting study that showed qualitatively looked at articles that have a certain template that says maintained, and we have people that actually maintain this article, which is usually just said to be housekeeping, but it turned out that it actually turned into ownership behavior. So this is my article. So this is the metaphor that I chose for that. So it actually this is the best quote from that paper. You should leave the article alone, because you don't know what you're talking about. This is my article. It's my baby. So that's actually what happens there. Because people, and here the social mechanism would be that you get vandalism to this article. So they have these maintainers. You get vandalism to this article, for example, or people that just don't know what they're doing, but they're doing good faith, but they're just really bad at it. Or there's mostly vandalists. And what you have is like these people that maintain the article, they get really protective about it. And then they build this defenses up. And the question is if afterwards everything goes back to normal, or these people still protect the article too much. So the good and the positive effect would be that actually we have no vandalism, we have only substantiated entries because they get through these gatekeepers, we have regular cleanups of spelling mistakes. Or the negative effect would be that we have overprotection, we have this information that does not get challenged anymore. And that is the very core of why Wikipedia is working, is because information gets regularly challenged by someone. So one of the pillars of Wikipedia says be bold. Just edit something, just challenge, and then maybe you get reverted, maybe not, it doesn't matter. But maybe here these people make sure that no new points of view actually enter because they're too cautious. That's an example of what I mean by these social mechanisms and how they look in Wikipedia. So these things that are described in the literature are indicators of that these things actually exist, that I hypothesize are there. So the next step, so this is something we described actually in a Web Science paper in 2012 and collected these things, these phenomena. So why is this relevant? So of course, scientists would like to know about that, if that exists, but more practically, so we have this long tail of articles that do not get many edits or views in Wikipedia, and we already discussed this over lunch, so a Pareto law is probably even underestimating it. I think there's a little amount of articles that get a lot of their attention, and there this many eyes principle works very well. It gets all the edits and all the views, but we have all these fringe topics and a lot of articles that get maybe 10 editors per month or per half year, there you don't have many people watching over these articles, and they are not in the watch list of many people. So you don't. It's not necessarily that they're bad, but nobody knows if they're good or bad. So if I'm reading them, how should I know if they're good or bad? I mean, there are some indicators, but
That's a question. So on the x-axis, higher values means articles get more attention.
Yeah.
And on the
no, and if you go on the right side, so there you get less attention to them.
Less attention. Okay.
Yes, and the left side is
got it.
more attention.
Okay.
So it's just it's not real data. It's just
right.
I think it's the Wikipedia power law.
Okay.
So the problem here is if I'm an editor, an occasional editor, or a reader, not even editor, because most of people are just readers. And they don't even know that they can edit. So now you look at articles, especially in these long tail articles, also in the other ones, but especially in the long tail. How would you know that this article is good or bad? And what you would naturally take as an indicator is the content, of course. You look at, is there templates? So there are typical templates that act as notifications that tell you, well, it's a featured article, is a disputed article, has a point of view problem, etc., etc. You look at references, which has been shown is one of the main things that people look at. How many references are there? Are the facts accompanied by these little numbers on the side? This means they must be right, and mostly they don't even check them. But these are some heuristics that you use. So the writing style, is it plausible, logical, what is written there? Does it concur with my own knowledge and the parts that I know of? So I can infer that the rest actually is also well written. But that's not what I'm dealing with here. That's people that try to do that, for example, by named entity recognition, looking at the references, co-referencing it with something. But the other side is the social side. So actually, what you would look like when you look at an article, like in a scientific article or in a magazine, what would be a different measure of to gauge if it's good or not? What would be? I mean,
The quality of the journal.
Yeah, the quality of the journal, or who wrote it, like the person who wrote it. So actually, that's
related.
Yeah, or who they related with, exactly. So who wrote it? What is their expertise? If I can actually assess that, or their tenure in Wikipedia or in that field. So what is and people have been working on this. So there's work by D'Alfaro and Adler. They have this Wikitrust metric where they can actually show how much stuff people have written that was not removed, and we actually improve on that as well. We'll talk about it later. But the main thing here is not only who have written which word, but how did the content actually in collaboration come to be. So who interacted, how and with whom for writing, on what. Yeah? And in that writing, in that process, were there these mechanisms actually that I described before? Mm-hmm. Not so much in the first step to say if they're good or bad, but actually to point people at them, because you cannot just print out, for example, a graph for every revision for them. That would be just too much. But to point them at things that they should look at. Like at this point in time, something happened. You should take a look at it if it was good or bad. Like if this mechanism turned out good or bad. That is the idea. And in the second step, you could actually correlate it with better good quality. That's another thing. So that's the main idea in the use case that actually would be used by many people, as far as I could tell from Wikipedians that I talked to. So for a deeper understanding of that, you actually have to know who works on what with whom or against whom. And in Wikipedia, what you have in terms of the data is you just have revisions of the article. Every single edit creates a revision. You don't have any explicit links between people. You have top pages, but they're really sparse. And you have the edits, of course, who edited what, which revision exactly. But in terms of actually who wrote exactly what in that article and what position or whatever, or who worked against whom, this is not explicitly there. So you have to mine it. So, but the problem with existing approaches that then I encountered when I wanted to use that was it's qualitative, like observing what's going on, or it's rather inadequate, and I don't want to slander anyone here, but it's kind of computer scientist approaches. I don't want to slander computer scientists because I'm working with many, but it's kind of, yeah, it works, let's mine that, and then there was no testing whatsoever how good this represents the reality of collaboration. It is done very often in very similar ways, but it was not tested. So what we thought is like, that's not good enough. We want to have stuff that we know that actually represents what's going on. So we want to have a very precise and fine-grained databases for this. So that's the mining part of this talk, the second part. So the first thing was reverts. So reverts, as it was understood before, is identity reverts. So let me give you an example. So this is a very short article, This is the first revision, and for simplicity's sake, we're going to assume that this is the one is written by one revision is written by one author, which is not really the case, but let's assume that. So there's a house, there are trees. This doesn't fit somehow. Obviously, is vandalism if I would have to interpret it, and then someone goes back to the second one. So this is a revert, like identity revert to the identical revision that was there before. This was happen. It happens a lot with vandalism, especially. But so then, what we would assume here is that everything in between was actually reverted. First of all, that is not necessarily the case. Someone might have tried to fix the vandalism but did not succeed completely. Then I would also assume that he was reverted by number 4, which would be number 5 then. Okay. But also, a different thing is, if I have number 5 here, then I would say that this is a partial revert of what's actually happening in number 4, but number 4 has reintroduced the first sentence, but it's actually number 5 obviously doesn't agree that it should be there. But with this old approach, you would not find that. The new approach is actually taking a much more fine-grained method. You can, first of all, you could find this revert actually, where 5 actually disagrees with 4. And this is a very simple example, but we had to test very many different settings to actually find some setting where we could be sure that it's an antagonistic relationship between these two. So this is...
Just a quick question. In doing a revert, is it, when you hit the revert, does it automatically save as is and then you go and edit that text? Or you can hit revert, edit it, and then the one save could show like number 5?
Well, there's not only admins have actually a revert button, like a rollback button. When you can revert so they have a rollback, so you can actually go back to number 1, number 2, and everything else is just deleted. Normal editors have only a revert between next to a revision. Like it would have a button next to number 3 here, and you would hit that, and number 3 would get removed. But many reverts also are just in the text. You just hit edit, and then you just remove it by hand, like by just deleting it.
So it's not actually using the revert function then?
Well, some people use it, but you cannot.
If you do use the revert function, does that also incorporate an edit, or are those two separate steps? I've never done this clearly.
No, it's just an edit. It's like an edit, but it's automatically performing an action, like going back to a certain text. Yeah.
Is that tagged by the system, like Wikipedia API, or are you manually looking for it using your...
I think it was tagged, or is tagged now, but it's not consistent over time. That's the problem, because they change it all the time, and there's no real plan.
So you did it like using code?
Yeah, but in this case, it's usually what's done. What we also did is just using hashes of the, like maybe 5 hashes of the revisions, and then comparing if the hash is the same. That's actually what we do. But that was done with the identity revert stuff, because that's really easy to do. But then I looked at it and said, okay, but that's not everything. So we don't have partial reverts, and there are other cases where you miss a lot of stuff. So that was we did, and then we evaluated it with 51 Wikipedians, and took samples of 5,000 articles, and actually we had plus 12% recall and plus 80% precision in identifying reverts that would not there were false negatives before, or there were false positives of identifying revert with the old version. So we combined the old version with this new one, and then we got these results.
So this is pretty low, isn't it? These values for precision and recall, shouldn't these be high?
Well, first of all, so these are relative. This is how we improve.
Plus, okay.
These are we
what was the raw?
The recall I cannot tell, because I don't know how many reverts are actually there.
Okay.
But because I guess that it's also in the range of 80-90%, because just by gauging what's going on in Wikipedia, and 80% in precision is also not that super good, but it's a lot better than it was before. So we could actually increase it more. We did not take into it.
That's good.
There's still room for that to increase it on the partial reverts.
I missed the plus in front of it.
Okay.
That's right.
So there was a paper at ACM Hypertext Social Media in 2012. And the next thing was authorship. So now we know we have a better understanding of antagonistic relationships between these people. And now we wanted to know all about collaboration, but for that, what do you use? I mean, Cindy, for example, you explained me that people do that. It's like, for example, you can look at, did people write something after each other, and they just added a revision, for example, and did not revert anything, for example. You could do that. But I want to go a little bit deeper. I wanted to know in the text, what did they actually write and where did they write? Because there are actually articles that are printed, they're 10 pages long. If someone will write something in the references or in the bottom, in comparison to someone in the introduction, it does not necessarily mean that they collaborated. So I want to know exactly what did they write and where. And there was no solution to that. So if we have an article, I want to know who wrote the word originally in which revision. By the revision, I also know who wrote it. So who wrote that this is a dynasty, who wrote that this is mountainous terrain, and who wrote that this is 99,000 square kilometers wide. I want to know who wrote that. Also, this goes back to this task I said before, just to know who is the writer of this, of single facts, for example. It's a little bit a different task, but it also helps with that. And there was no satisfying solution. So what you have in Wikipedia are these revisions, and what they provide, for example, and what many people do is like diffing, like making the text difference, what is deleted and what is added. But usually you compare two revisions. This is a completely different task than finding out who wrote this specific word, this specific fact in the history of all the revisions for the first time. Because you also have to take into account reintroductions of all the reverts. Like it's vandalized, then someone else recreates it. That doesn't mean that the recreator is the original creator. So this happens a lot. You have to take that into account as well. So, and they have been. This is a problem that you actually also have in code repositories or any textual version system where you actually have textual revisions and you want to find out who exactly wrote that. So, for example, code systems only use line, who change a certain line, which is kind of coarse grain, and they also do that. So in Wikipedia, there was a lot of approaches. They were sometimes kind of naive, sometimes they were more comprehensive, but they were never really tested because nobody cared about testing what they actually do. So in terms of precision, if they really tell you exactly if it's correct that this person actually wrote that word. Then we did that a little bit. There was preliminary work in 2012 where we tried that and tested Wikitrust, and both of them were not really precise. Then there was another approach by Look at the Alpha Roll last year, where he tested the scales well, but he did not test the precision. So what we did then, we looked at exactly what's happening in Wikipedia to improve precision and also the runtime. So what was done before is like comparing every single on token level, on word level, comparing all the revisions with each other and all the history of the revision. But we thought we don't have to do that. We only take what has not changed in the biggest chunks that we can find, paragraphs, sentences, and then we only go to words if there's a change. And in this way, because there are many reintroductions, there's a lot of moves, there's a lot of small little changes. We don't have to compare all the time. First of all, because it's expensive. Second of all, because it introduces inaccuracies. And with this large chunks tracking, we also maintain the context of where a word was, which is important. If I want to say if this and this and was introduced, I have to distinguish the two. Yeah? Because this and in this sentence is a different and than in the other sentence. Therefore, I need the context of that word. So what we did, we actually built a graph model where we actually split it every revision. We had the node was a revision with a paragraph, with all the paragraphs as children nodes, with all the sentences of the paragraphs as children nodes, with all the words and special characters as children nodes as well. And we built this very effective and efficient graph model index structure where we can go through very fast to recreate all the revisions and actually track what's coming from where. So I'm not going to go into detail how this algorithm actually works. So this is, if you want, I can have some backup slides for that later on. I evaluated that with over 800 Amazon Mechanical Turk workers and 260,000 revisions, and here we have 18% precision in gain, so 95 total in precision. Actually, who's telling it's actually coming from this person from this revision, and we really made it much more scalable. So actually now it's feasible to run through almost the whole Wikipedia and through big articles in a realistic amount of time. Which with the diff algorithm sometimes takes days or hangs up because diff is really sensitive to this kind of vandalisms, and sometimes it gets hiccups and doesn't run anymore. And we created a gold standard actually for this, the first gold standard to actually evaluate if if you're really right in saying where the words come from. Of course, this is also applicable for other revision content systems, so just as a side note, so for code revisioning or whatever, and if you're interested, the code is also available. So this was, the preliminary work was in 2012, and now last month in dub I presented the paper for that. Now we have this data, so now finally I have the data to actually accurately say what comes from, who wrote what, and who reverted whom. And the next step that I'm currently working on, and where the collaboration with the expert in social networks comes into play, is actually to model this into a higher level form. So to operationalize this somehow. So define metrics or models, social network graph models, for example, to capture these social mechanisms or these interactions, and also over time. Yeah. So this is, for example, something that Aaron does. Where I also already talked to him, Aaron Scheck here. So we already played with simple metrics as approximations. For example, we can do authorship concentration now, which means we have a Gini index from 0 to 1, where 0 is all the editors wrote the same amount of the article, and 1 wrote everything in the article, all the words. And for example, we have a little tool that graphically shows this over time, over the revisions. And for example, we can spot abnormal behavior here, where suddenly the concentration increased. And before, these little spikes, for example, show when vandals replaced the whole page. So one vandal owned the whole page. So you have vandalism in front. So what we can do, for example, there, so that we come back to the social mechanisms, this ownership behavior is, for example, linked with what I described before, is linked to a certain template. So what I have a student look at right now is actually if these kind of patterns in this simple metric plus some other edit concentration metrics, but they're also kind of simple, actually somehow are correlating with these introduction of these templates, or after the templates get introduced, after these maintainers get announced, and so on and so on. But of course, it's not. It's not showing you everything in the data. So the next thing that I want to do is actually, or what I'm currently working on, is building social graphs that can actually tell me more about it. So building a matrix of these editors with the data that I have now, the authorship and the revert data, and do this building on prior work that has been done in this regard, especially in Wikipedia. So this is something that I'm doing right now, and I'm trying to figure out how to best put this into a social graph. So Brandes, for example, they have done they have done something in 2009 where they only used, because collaboration, like the positive interaction was not that much available, so they used mostly only deletes and undelete stuff. So all the edges were negative links. They're not directed, but they were negative links between, if they remove words of each other, they would have a negative edge, which was actually weighted by the number of words that were removed. So that's what they did. But their main contribution is actually something else. So this is just a choice how to model this. They actually proposed a very interesting projection into controversy space, where they actually not only have like a bilateral clustering, but they can actually say for each node, just by the negative links that they have, how much they pertain to a certain node, like how much they actually are part of a group. This is something, for example, I try to use right now in modeling, for example, opinion camps between people. Mm-hmm. Still working on that. Another approach was by Manio et al. They actually did a directed network where they use deletes again and replaces and reverts for the negative links. They're directed and signed. And for example, when someone restored someone after vandalism, for example, there's a positive links, and if someone inserted something, wrote something in a revision, like mm-hmm. 1 or 2 days after, and without antagonizing him, then it was a positive link. And possible extensions to this that I'm right now contemplating are partial reverts. So you can actually look at, because before they only used identity reverts that were only available before. Also, they only used very well. I have more
Can I ask
reverts.
a question about that? Did they model this? Did they aggregate all this data and look at it as a single social graph, or did they model it relational, as in like relational events? Like
No,
one
no
and
events.
okay.
They just do snapshots.
They aggregate two snapshots.
They don't even
Okay.
they don't even do snapshots. They just made graphs at a specific point in time. Mostly it was the most
Okay.
recent revision, and then they just show it.
Okay.
And the evaluation was done by showing that the graphs differ for different categories, for example.
Okay.
So, and for example, what you could do here, what I mentioned before, collaboration can be modeled. For example, if I do edits closer to you in your section, or it's actually it's like a mutual way. I added something and you added something again. I added something again. We're staying in the same section. So that's still decisions I have to make, and where I also would like some input from some experts how you actually would model that as a collaboration edge, for example, and then over time, for example, and I would like to use this controversy projection actually to consider also positive links. If I don't know if that's already there, or that's for example something. So now coming to this longitudinal social graph, like over time. So let's take this use case again of the ownership stuff. So maybe this is the simple, just as a helper, the simple concentration measure would help us, but probably that's not enough. So here's a hypothetical example how, for example, I would imagine the graph would change in this example. So we have the blue are here, so these are the little bigger ones. They are the maintainers as proclaimed by the template. And we have pretty normal relationships. People revert them others a little bit, but nothing much happens. Then, for example, come along vandals. Like there's a vandalistic phase, which would be concurrent with this spikes here, for example. And they start protecting. They start throwing them out again. Maybe it's people that just too naive to know what they're writing. And then at time point 3, or however that looks like, we have a completely different picture. Now these people own. So let's let the circle size be the number of content they own. They own much more all of a sudden, and they're actually opposing not only vandals, but they're opposing kind of everyone, because now they're super protective of the article, and they have developed this stance that everybody else just don't know what they're doing. So this is something hypothetically that I think might be there. This is kind of an example of a graph pattern where a social mechanism is actually captured. This is what I'm trying to find right now. Another example would be just say so. So this would be actually as you get a new edge or a new version of the graph, every revision is really, really fine grained. So every revision, every edit that is done creates a new version of this graph. So the other question is how you would represent that. If you only use the last 100 revisions to build a graph, if you have a decay function, maybe for that, for example, some edges decay over time because it's not relevant anymore for what's going on right now. That's some questions that are still open.
On the last one, another sort of ownership dynamic that I could see taking place is that you might have someone who has a lot of stakes in terms of the information that's put out there on the Wikipedia page. They might find out about it much later, so you might see the genie sort of dip when they come in to alter it and frame it more in their sort of towards their preferences. So you might see like a new entrant come in, and the genie might dip in that case. Isn't that sort of what you'd see with the genie? It might dip.
Yeah, it depends when they remove stuff from someone else. It depends on what if they remove something and what they add. Because if they, for example, if the article was like let's say 2 sentences long and they add 50, then it would go up.
Okay. Yep.
So that's why the Gini coefficient is not that good of a metric. That's why I need more sophisticated metrics, because it's very context specific what it says. And also it does not say that it's bad. I mean, this can also go up just by these people writing more. Then it does not mean that they are actually opposing people now. What we see in this graph, it could just mean that some guy comes in and extends the article, and it's really, really nice. And there's nothing going on actually. So in many featured articles, I actually have high concentrations so far that we can see, because people just put a lot of work in them. So there has to be a combination of these simple metrics over time with something more complicated, more comprehensive. That's actually where I need some input. So another example would be this opinion camp thing, where we also have some. It's not as nice as with the maintain template, but we have templates that can correlate with this, and we have this Conservapedia case where I know of the actual articles where this took place, where people actually. So it's not a normal edit war, but it's more like you actually, because edit wars are there all the time, that people revert each other back and forth. That's not unusual, and it's not unhealthy, as far as we know. Actually, it's healthy if you have a little bit of conflict. But if they really get these camps that do not dissolve anymore and only revert because they're in the other camp, that's unhealthy, probably, or could be. So in this case, maybe we would have something like this. We had a lot of revert war going on over time, and in the second time point we look at it, then we have these editors, the liberals, for example, have taken over the evolution article, and the conservative users actually have lost all their content. This also would be interesting. So now we would, for example, see, let's go back to this, that this pattern, what we would test is actually this, is there a pattern in all these templates, in all these template maintain articles, where we actually know that there are these maintainers? And if you take a random sample, do we find something that is conclusive, it's always this kind of the same pattern in them? And then where does it appear and which point in time? And if I take a random sample of other articles, does it less likely appear there? Then it will tell me at least that it's kind of typical for these template maintain articles. That's something how you could test it, for example. The same with this opinion camp behavior. Then again, so far I did not really judge in one or the other direction about if that's good or bad. I said it can turn out good, it can turn out really bad. Both is possible. So what you can do up top, and this would be the next step, is actually say, is it untypical, for example, feature good articles when these do not explain any of these social mechanisms, or do they display them as in the same way or more, or in a different context, or in a different combination? Or you could actually ask people if what is the quality at a specific point in time in the process. So either you have templates there that get removed or added somewhere in this process, or you externally get assessments from other people. For example, crowdsourcing workers, and I have been working on that as well on the side. It's kind of a side project to actually crowdsource articles, Wikipedia articles, especially in the long tail, to actually ask people if they're good or bad, to see if they just don't have, for example, bad quality indicators because nobody looks at them. But it's kind of a optional plus on this research.
Is the most common way then just to see whether the article was featured? I mean, what is the most common way what was the most common quality indicator?
Yes. So for research, it most certainly is featured articles. If you look at how, I can talk about computer science research, if how they measure quality, it's almost exclusively with featured articles.
Mm-hmm.
Because this is just the one thing where you can be really sure that it's good. Whereas with the bad quality indicator, you can never know who put it there, if it's really good, or if people had different reasons to put it there. Like have put it there because of different quality issues. Some people can say this is disputed, and any other one can say this is maybe not disputed, but it's non-neutral. Yeah, so usually it's the feature. But they're kind of sparse. So and they're only in this one not long tail thing because they're super long usually and super elaborate, so they're not in a long tail.
So how does crowdsourcing help with that?
You could actually, what I would like to test, if I find a time where I started to do that, is actually go to the long tail and ask people, are these and these articles actually bad or good?
Who would you ask?
Crowdsource, Mechanical Turkers, for example. Or I was playing with the idea to actually put it on Odesk, because Odesk has bigger tasks. So they have actually like freelancers, writing freelancers.
Because by definition, the long tail, there'll be very few people who are qualified to take on that task. And so how do you decide whether you get somebody who's not very good?
Not necessarily.
Okay.
So it could also be a recipe on baking a cake, which actually almost everyone can at least rate in terms of readability, or you could also rate in plausibility, mm-hmm. or in how is it written, blah, 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 blah. So it's
not all esoteric.
Exactly.
Okay.
So not everything is so fringe in the long tail that you cannot rate it.
Okay.
But then you can actually spot if there's these missing bad quality indicators or warnings are just not there because nobody looks, or are just not there because they're not that bad. But it's kind of a little bit sidetrack of this stuff. Well, yeah, that's the main research part that I just presented, that where I need expert input from social network scientists because I know about how to deal with them, but this kind of specific stuff is really, really special. Well, this is this, and on top of this, what I'm doing already is like to actually make the data available and build some services on top of that. So not only for researchers, but also for Wikipedians themselves. So we already have an API in a very early alpha, not early alpha, it's an alpha, where you can actually query every single revision on the fly of Wikipedia for the authorship of each token or word in there. And I'm currently adding the reverts as well to query for them. And simple metrics like the concentration, like this Gini index. And then in the future, I would once I have them, that you can actually enter parameters for specific graphs you want to have from this, and it gives you on the fly, gives you graphs for each of the revisions. That's what I'm envisioning. So I'm working with Markus Strohmeyer, which I'm starting my postdoc with, and we're actually planning to offer this as a service to social scientists. In particular, because they mostly don't know how to use the algorithm or how to run it themselves. No offense, but mostly no. So actually, because it's so efficient, we can do it on demand, and we can do it for the whole English Wikipedia, and you don't have to wait for hours to actually get it back. And then, of course, visualization. So we have you have different simple graphs. We can show the concentration or different other measures. For example, who are the editors who own most of the stuff in the article, who wrote most of the stuff. Then there's something that already exists that I'm currently adapting, just a visualization. When you go over, when you install that in your own account, you can actually see for each revision who wrote everything here. So it calls the API and actually gets markup for the text. This is an interface that was developed for Wikitrust, but which we adapt for our stuff because it's just faster and more accurate. And of course, that would be the how do you say Königsdisziplin? How do you say the Queen's discipline? Like the last thing that you would have is like to have an interface actually for Wikipedians where they can go through these kind of graph structures. Of course, not for every single revision for the graph because it's just unfeasible to understand. But to have something that somehow summarizes the important things that you have to look at. For example, highlights them. Like this is typical for a disputed template. So maybe you should look at what's happening here. Because maybe this article does not have a template, but the social interaction goes on here is somehow unusual, or somehow it's typical for something that's not right. Or it's typical for something that goes extremely well, usually. So, but I don't want to judge. I just want to show people, look at this. This is worth looking at, which is already a big help in terms of judging the article. Of course, the next other step, if that's possible, is actually to do a more definitive stance and say, like, okay, this is usually biased if that's appearing. But that's, well, I'm not sure if that's feasible to do. But at least saying, like, it's typical for certain templates would already be helping.
So what you're calling... Oh, sorry, your word's complete. I'll wait. I'll hold my question.
Yeah, it's only one.
Yeah, go ahead.
So the summary is actually, why is this important? So define these social mechanisms, if they're actually these social mechanisms, if they appear systematically in Wikipedia, and if we can actually identify them in a way that we can say, we're sure that it's the same social mechanism. Second thing is give users some way to inspect articles with using them. That's what is important. And what you already have is like we collected these phenomena that act as indicators somehow for where we think there are social mechanisms actually happening, and we have this accurate revert and authorship data, and we have some proposed simple metrics and graph models that we now have to extend on, somehow build on. And that's actually decide on these final appropriate graph representations and other simpler metrics, and then actually look for best methods to find these patterns in the temporal data. Yeah, and then maybe set them in relation to initially described phenomena. Build servers is what I just described. Okay. This is just before I completely finish. So some other stuff I do, which is completely something else. So I'm also interested in other platforms, especially Reddit is something where I just had a paper at Web Science track as well, where we looked at how the Reddit, a social bookmarking platform, turns more and more to itself and is more concerned with itself than with the outside web. we hypothesize it's because they have a growing culture and more reference points to themselves. We also have a lot of data there, if you're interested. Well, human computation in general, because I do it for experiments for my papers usually. I use Mechanical Turk, but also do some work on semantic web query, human computation crowdsourcing with a colleague of mine, which is her topic. And some other things I do with students is, for example, gamification of Wikipedia articles, where you can actually play. This is a different approach to edit Wikipedia articles, because they have the problem that they don't have many editors anymore, because obviously it's not attractive to go to Wikipedia and edit. So we try to have a gaming approach where we actually people can play an article or a revision of an article and can actually find errors and get points for it, or find other things and get points for it. So it's also a side project I have a thesis on with a student of mine. Okay, that's finally it. Thanks.
Great.
And
Thank
questions.
you. So we have about 10 minutes for questions. Who wants to go first?
I have two.
Okay.
Okay, quick question about quality. So why not use not only the featured article status, but there's the good article status, and below that there's ABC, and then there's also stub, and then there's start articles. Can we use that as a determinant of quality instead of using something that's more subjective? Because if you submit it to Mechanical Turk or whatever, it's a lot more people, but with these ABC, they're being ranked by the same group of people, so there's some consistency.
Okay, so the question is, why don't we use that for what exactly?
The quality, because you were talking about how you expect different patterns in lower quality Wikipedia pages than the featured article pages.
No, I don't necessarily.
Or not that you expected, but you were thinking that it would be different. Or testing the.
So it's a different approach, but it's a good idea. I mean, so the approach would be if I find, for example, patterns that match these social mechanisms, if I find them in good articles or not. Well, I will certainly do that as well. But this was more theory driven, so this was more like a machine learning approach thing, like exploration of good articles and actually find typical patterns in them. So this approach is somehow turned on the head. It's I think there is something that is everywhere in society usually. I would like to know if I also find it there. And where I look first is the articles that are indicated by related literature, where I think I could most probably find them. And afterwards, I will go to the featured article set and see if I find them there. So it's a kind of different approach, but you're completely right. I mean, there is a lot of good article tags, so yeah, I would definitely do it as well and look at them.
And your second?
My second question was, you talked about not having an answer to the question about what is collaboration, and on a Wikipedia page, and I was just thinking that if you're looking for patterns, why not look for them on multiple pages? So what happens, have you considered looking at if I edit the top of a page and then someone edits the bottom of a page, well, can you go and see if that pattern exists in the other pages that we have co-edited together? So one of the projects that I kind of am doing on the side looks at just the number of pages that you and I have co-edited together, and that number is pretty frequent, it's pretty high for a lot of the editors. And so I'm imagining there's a bunch of task forces that go out, and can you define collaboration using patterns in multiple collaboration settings? Yeah,
that's certainly a good addition to that. Yes. So, for example, when I look at the two maintainers in that example, if I look at do they maintain an article together somewhere else as well, and then I could, for example, put them closer together in that graph, so they're more likely to collaborate. The other question is if you would like to do that, or if you start mixing up things, because there's also the case that many editors take completely different roles in different articles. So sometimes I'm the expert, and sometimes I'm only the maintenance guy who only does the spelling check. So the question is if you would mix up things, or if you would like to stay per article. But it's certainly something you have to take into consideration as well. Maybe it helps. Yeah, I'm not sure.
Can I search for Cindy's edits?
For Cindy, yeah.
So
if she has a profile, if she's logged in.
If I want to follow everything she's doing and keep editing it,
yes,
that's easy enough to do.
Yes.
Because I'm trying to think what are the coordination efforts and how do they manage that in situations like I know you said there's a wiki project where it's a coordinated effort,
Exactly.
and that happens in a different domain or different forum where they choose which pages they're going to work at.
Right.
So I'm just trying to think, how do you find that emergently if you don't have access to that
You
coordination?
can also set up alerts, right? That if someone changes something that you
Yes,
edited,
it's very
it
important. Watch
automatically-
lists are
Yeah.
very important. So watch lists is why maintenance actually works and why vandalism
Doesn't survive, yeah.
It doesn't survive because I mean, if you go to a very popular article and you edit, you write crap, then in 30 seconds you usually revert it.
Stephen Colbert proved that to us, if you remember, a few years ago. Was it Stephen Colbert who had the edits for the elephant? Was it or something? What was it?
I can't remember who it was, but right
Yeah.
here did something.
Yeah, he was a very famous television person here who told
Yeah,
everyone
yeah.
to go make a change. Yeah.
That's funny.
Funny, yeah.
Well, that's another thing. Yeah. That's
Another
another
thing that you could capture is like, I wonder if there's a large group of people who don't know that they're editing the same subset of articles. So it's like, if I'm editing this page and it's my topic area that I'm interested in, but I might be doing it like in cohesion or like collaborative effort as someone else, but it's not conscious. So I was thinking about what's the determining factor between like conscious collaboration and like unconscious collaboration.
Yeah, but I'm pretty sure, as far as I know Wikipedians, that if you're really invested in an article, then you know who's working on it as well.
That's true.
Because you check who wrote who changed your stuff, so you're pretty aware of at least the frequent ones.
Well, so there's a general pattern that I wanted to see if I'm getting the gist of, okay, and what you're doing to see if this is. And that is, one of the things you're doing is you're saying, I'm going to look what you call templates. In networks, they are sometimes referred to as structural signatures, certain kinds of patterns that are showing up.
What I refer to in templates here is it's explicit pieces of code in a page.
Okay.
So it's like there's a little bit of code, and it kind of includes as the code from somewhere else. So it puts a little badge on your stuff. So
Okay. So when you showed the word template as a caption, very often what you had was little arrows, certain sequences of arrows. If you go back, you had certain sequences of arrows between nodes, and you said like these ones.
Mhm.
You said this is typical for a template of disputed. So in other words, what I look at those lines there, what I see is a structural signature of some kind. And you say if these kinds of signatures are more commonly found, where there's a couple of large nodes that seem to be negating everything else or
exactly.
everything else,
Yeah.
that to me is a structural signature.
Okay, yeah.
Okay, it's a certain pattern.
Uh-huh, yeah.
And so part of what is a common theme in social network analysis is you define these structural signatures, and then you count the number of times that they happen in that particular graph. Okay?
Okay.
And then you assess the extent to which those counts happen more than you would expect by random.
Exactly.
Okay? And part of what you're then doing is, and then that builds up. We can build up looking at multiple structural signatures at the same time, some of which are nested in others. And that allows you to then not have to binarize and say whether this is disputed structural signature, this is disputed or not. I mean, is this the ownership idea that you had? Is this ownership or not? But instead, you can put on a scale of 0 to 1
Yes.
the extent to which you see ownership on this, and the extent to which you see each of these other things on it, and then look for how those might be predicting quality indicators, whether it's performance, whether it's in terms of featured, some of the ways in which Cindy talked about, going down below good, A, B, C, D, and so on and so forth, or your mechanical Turk ideas.
Yeah.
And I think that would be a very valuable way of increasing our understanding of how team collaborations are happening in this context in a way they've not been able to do, because one of the things that is distinct about this context is you have very micro-resolution negative things, reverting back to editing in the negative, removing things, etc., which in most other contexts we don't have good metrics of negative collaboration. We also have ways of using this then to detect the expertise of people, because you see what are the kinds of words that they're adding and what are the kinds of text they're adding. So across a large number of pages, you can begin to say, I think Fabian's expertise is on these topics, because if you're able to look at the words that you have edited. Okay? And that becomes very handy, because several years ago, there was a project that came out of Cornell called the Wikibot Recommender System. I don't know if you've heard of that.
Oof, I don't know.
This came out of Cornell, and the idea was that one way to improve edits on Wikipedia is if I know what your area of expertise is, I will. People come to Wikipedia and say,
I'd
"I'd like to."
you, yeah.
Yeah, it's a recommender system. Otherwise, I want to help, but I don't know where to go looking for it. So if you install this tool, then it'll say, "Give me your areas of expertise," and I will send you to pages that you might be interested in.
Exactly.
Recommend pages that you might be interested in editing. But that relied on people providing their self-report on what their expertise were, which sometimes people are not very good at.
Yeah. Exactly.
But if you use an approach like this, and you're able to see the extent to which not only what revisions people put, but then which revisions that people put are sustained and not necessarily removed immediately, will over time begin to get you a much more accurate measure of this thing. Now, one last comment about this. You talked about one is more machine learning, one is more theory driven. To me, I think that there is that's not a distinction that I think needs to be as of concern to you, because once you have these structural signatures, you may hypothesize which of those are likely to be associated with high performance, but then concurrently, and we've done this in other cases, you can take those structural signatures and throw it into a feature list and see what comes out, and then look at the results to try to interpret them and see if you can make sense out of it. Sometimes it may not be, but certainly things like decision trees may allow you to see, oh, I can have a more complex theory now of why certain combinations of ownership and or something else, if prevalent, could be associated with more successful articles or not. And so that's a strategy that we've been using a lot in the lab right now, simply because we don't think that social science theory is as well developed, where there is no benefit to going and looking at what results would come out of a machine learning model.
No, it was not meant like that. It was just
I know. I think you're in a
approaches.
good position to do that, and this is one of the advantages of computational social sciences, that we have the license to do both of those kinds of things and use it judiciously. So I'm going to have to sign off, and we're going to close the connection here, or let's thank one more time Fabian. A round of applause. And we continue to have a discussion.